In this video, we're going to take a look at another quantitative risk assessment. This is a risk assessment prepared by the United States Food and Drug Administration. Let me describe the problem that they were dealing with. In the United States, our chicken producers sometimes use antibiotic drugs in the food and the water that they feed to the animals. The thought is it holds down disease and it also limits the growth of bacteria. Now, in this particular case, the Food and Drug Administration was looking at the use of fluoroquinolones. These are antibiotics that are also used for human beings. The fluoroquinolones were used to try to hold down Campylobacter, which is a bacteria pathogenic to humans that is commonly found in chickens. The problem is the fluoroquinolones are given at subtherapeutic doses, and that means it doesn't kill all the bacteria. And some of the bacteria that survive the survive the fluoroquinolones develop a resistance to fluoroquinolones. If those Campylobacter continue to reproduce and remain on the chicken all the way through processing to the point where we bring the chickens home with us, if we don't cook the chicken well, or if we cross-contaminate the meat, we could end up consuming chicken that has fluoroquinolone-resistant Campylobacter on it. So if we get sick, usually we tough it out, but some people will go to the doctor, and sometimes the doctor will ask them to bring a stool sample. That's a messy sort of thing to have to do. A lot of people won't do it, but some will, and then the doctor will find out it's Campylobacteriosis, and then they would prescribe fluoroquinolone drugs. But those drugs will not be effective because the Campylobacter will be resistant to fluoroquinolones. And that's the basic problem. The Food and Drug Administration was trying to find out how big a problem is it in the United States. So we're going to look at this risk assessment. You see 2 years here. This assessment's a little bit old, but it's still a good example for us. The details don't worry about. We're not going to dig into this, to the math or the logic or anything else. All I want you to see is this. This assessment is broken up into sections. And we'll begin with Section 1. In Section 1, what this risk assessment tries to do is estimate the variable number of people who would have culture-confirmed cases of Campylobacteriosis. In other words, their doctor diagnosed and knows for a fact that they have Campylobacter. And that doesn't happen that much because if we get sick from food, usually we have a rough day or two, but we don't go to the doctor. Notice here, there were 28,000 cases of non-bloody diarrhea, 24,000 cases of bloody diarrhea, and almost 600 cases of invasive Campylobacteriosis. This is when the bacteria gets into the bloodstream and it's a very serious illness. Section 2 is going to build on those numbers from Section 1 because we know that not many people actually have their illness confirmed. So if you take this 28 plus 24, that's 52 or 53,000 cases of confirmed Campylobacteriosis. What we would like to know is how many total cases of Campylobacteriosis did we have in the United States? And Section 2 estimates that from these numbers here to this number here. So in this particular estimate we're looking at, we see about 1.6 million cases of Campylobacteriosis in the United States. Section 3 is the last section we're going to worry about. And here we begin with that 1.6 million, and we would like to try to find out how many of these 1.6 million cases were associated with chicken. And the answer is found here. About 700,000 of those cases were associated with chicken. And of those, how many were fluoroquinolone-resistant Campylobacter cases associated with chicken? And the answer is about 127,000 cases. So of all the people who got Campylobacteriosis, about 127,000 people were made sick by fluoroquinolone-resistant Campylobacter. Now, that's a problem, but it's not a problem that we're concerned with until these people go to the doctor. So this remainder of this section is telling us how many people go to the doctor how many get treated with antibiotics, how many get treated with fluoroquinolones, and people who go to the doctor, total number of fluoroquinolone resistant infections from chicken for people who are seeking care, getting fluoroquinolones and finding out they're not terribly effective. That's the number that we're after. And that is about 8,000 people out of that total 1.6 million. But of course, there's a lot of things that are unknown to us. There's a lot of natural variability in this, and we're not going to worry about those details and how that's done. But what I would like you to understand is that all of those red inputs that you're looking at there, they're all things that are uncertain. And so this number right here is one that we really don't know. It could be 7,000, it could be 10. We go back to the mean and it could be 9. And so it goes. So we are going to run a simulation. We're going to calculate this number 10,000 times starting now. And you'll see this come up and it'll begin to calculate. If you look over on the right hand side, the statistics, the minimum and maximum, we're going to keep a little eye on that because what we're trying to do is gauge the magnitude of this problem because we don't know how many people are affected annually. Now so far, if you're looking, it looks like it could be as few as 2,400 people in a country that we now have over 300 million, but we had closer to 290 million back when this was done. So 2,400 people it could be. It could be as big as 75,000 people. But the average of all those 10,000 numbers was 8,767. So how do we report the numbers? If you go to the boss and try to say it was 8,700 people, that really masks the problem. The problem could be much bigger than that. In fact, let's take this delimiter and scoot it on over here to 10,000, and we can see there's a 27% chance that it's more than 10,000 people. So that's important information. 2,400 people, maybe the boss is going to say, that's not a big enough public health problem for us to worry about. 8,700 people, I don't know. That might be on that edge. But when we tell the boss that it could be as many as 75,000, that might begin to change things a little bit. So we need to be able to give our decision makers more information. In the other video, you heard me speak of the 5-number summary. You should never use a single value. When you've gone to all the trouble to develop a distribution like this, when you report it to your boss, to the public, or to anyone else, you have to really work hard to avoid narrowing that down to a single value. There's one other thing that I will show you we can do here because there were 2 years, so I'm going to add another distribution to this. I'm going to say add this distribution. And now you're going to see that the red distribution was 1998. The blue distribution is 1999. And what I'd like you to see here is the entire distribution is moving to the right. Moving to the right is a bad thing. That means more and more people are getting sick. If we scroll over, that mean of 8,700 is now up to 11.5. You'll also notice, just by dumb luck, since we're doing simulation, and you'll learn about that in the next 2 classes, the maximum for 1999 was actually less than the maximum estimated for 1998, but that's a dumb luck result that comes from simulation. Here's our bottom line. When you are doing risk assessment, whether qualitative or quantitative, there are things that you do not know. We need to examine, we need to estimate the effects of those things we do not know on the criteria that we use for decision making. In this case, the number of people who get sick. So, back to here, back to look at this distribution. You cannot pick just one. In the risk assessment that we were looking at, just one number, excuse me, in the risk assessment that we were considering earlier from Matagorda Bay, we were concerned about low-end values, negative net benefits. Here we're concerned about high-end. So we would have to find ways, working with risk managers, to find out what their risk appetites are, because there are a variety of ways to try to figure out what the values of most interest are. Here, as I mentioned before, 10,000, maybe if we let the boss know there's a 1% chance that this problem is affecting more than 20,000 people. And of course, if we were looking at 1999 and years after that, the probability of a larger number of people would grow and grow. So, decision-making changes with risk assessment. There is no longer a one-dimensional kind of decision-making. We have probability and we have quantity. At a minimum, we have to work with those two.